So our final talk in this session, before we get to our panel discussion, is from Nvidia. Our speaker today from Nvidia is Justin Boitano, who's Vice President and General Manager of the Enterprise and Edge Computing for Enterprise and Edge Computing at Nvidia. He has more than 19 years of business leadership experience and was previously Vice President of Marketing and Business Development at Frame, which was a cloud-based application delivery service acquired by Nutanix. And prior to that, he was general manager of NVIDIA's enterprise virtualization and cloud business. And Justin's going to talk about thinking on the edge from NVIDIA. And with that, Justin, you can go ahead and take it away.
Awesome, thanks, Bob. I appreciate the intro there. And as you can hear, I was at NVIDIA before. I came back because NVIDIA is really transforming and revolutionizing AI. And when you look at AI and you stand back, what you realize is it's one of the most I say powerful technology forces of our time that's going to revolutionize every industry. And when you think about it, what's happening with AI is software is writing software that achieves results that no human written software really can. And the scalability of the approach has really started a race to create larger, more complex models and more capable AI. And really what this chart shows is how much compute is going into building modern AI models. The combination of building new models with more data requires state-of-the-art models to have over 30,000 times the amount of compute put into creating the models in less than 5 years. And that's really doubling every couple months. And the results of this AI is spectacular. If you look at NVIDIA's natural language understanding, AI, we took the race reading comprehension test consisting of 30,000 pages of reading and 100,000 multiple choice questions. And the average human scored 73%. Human experts can yield 95%, but these NVIDIA Megatron BERT model scored 91%. So AI is achieving better results than average humans for reading comprehension. Users of chatbot services also prefer AI models that have human-like, emotion and personality and knowledge and empathy to other like previous built models. And Facebook has kind of been leading that charge. In terms of drones, there's reinforced learning models that can deal with can build flight control systems that fly smoothly through turbulence terrain or aerodynamic effects. And that's kind of just the start of AI. When you think about kind of what goes into AI, it's an incredible computing challenge with big data sets, big models, and it's pushing the limits of every aspect of computing, from storage to compute and to networking. And so we're working to democratize AI through kind of 3 pillars of computing. First is data processing, feature engineering, and training at any scale, whether we're talking 1 GPU, multi-GPU, multi-node, in any cloud, using any framework with any model. The second is inference, which is really a great computing challenge, obviously, for the industry. NVIDIA TensorRT is a graph optimizing compiler for huge complex graphs that target a device while optimizing for a bunch of competing constraints, whether it's accuracy, throughput, response time, or memory size. And we recently released TensorRT 7.2 with over 2,000 kernel and layer optimizations. So TensorRT has been downloaded over 1.3 million times, used in 16,000 companies, and runs over 300 services around the world. Triton Inference Server is used by data centers to deploy multimodal AI, and more AI is going to multimodal types of AI. NVIDIA transfer learning tools let customers take pre-trained models and refine them for their own data sets to optimize usage for their domains, like refining general language model for engineering speak, as an example. And then the third pillar of our AI is our application frameworks. And these are pre-trained models, transfer learning, runtime engines for some of the most challenging AI applications, like self-driving cars, robotics, drug discovery, conversational AI, recommendation systems, et cetera. Vision AI is another common one. Thousands of NVIDIA engineers are working on NVIDIA AI today, and thousands of companies around the world are kind of running their businesses on AI. So it's, I think, important, for us all to work towards, these peer-reviewed types of benchmarks and tests, so we can all, look at kind of how all the architectures compare to one another with real-world scenarios that the industry agrees are kind of the common frameworks that need to be looked at, both in the data center and the edge. And the reason that it's important to look at this from data center to edge is many of the companies that we work with, for example, want to build and train and test their models in the data center, and then they want to deploy it out to a car or out to a robot. And you want the same model to run on the same architecture, whether in the data center or the edge. Now, through MLPERF, the organization has added a couple, there was 4 new models for medical imaging, speech recognition, natural language processing, and recommendation engines to reflect, many of the common uses of AI. So there's many different types of benchmarks that are peer-reviewed, running in many environments in a bunch of different scenarios. And the beauty of this, obviously, from our point of view, is we were able to use a common architecture to run every single test. So the great thing about our investment in GPUs is the goal is for them to support, obviously, varying accuracy levels, be able to run every model, and be able to run them with confidence that you get sort of the full performance acceleration. And so some of these results, the results are normalized in the data center side to our T4 GPU, which is widely deployed for AI inference and training, and is being deployed both in data center and at edge. And you can see basically our new Ampere GPUs and the performance gains relative to T4, and then everybody that has submitted against this architecture with running all their different workloads. And so if you look at, for example, NVIDIA recommendation system, or the recommendation system relative to CPU, you get a 237x increase in performance versus running CPU-only infrastructure. So, you can quickly and easily get to, one of those value equations that show you the more you buy, the more you save. If you're running AI, you can buy less servers, but have them accelerated and give you better throughput and better results. On the edge side of this, and this is where I spend most of my time now, is actually on the edge. We see similar results, whether we're talking single stream or multi-stream, data sets. We basically, again, here normalized everything to our NVIDIA Jetson AGX, Xavier. And you can see NVIDIA GPUs are kind of accelerating every workload. And we have a range of architectures, so you can right-size the compute for how much throughput and the type of work that you're trying to do, across this range of use cases. And so I think NVIDIA sees AI computing as a full stack computing problem. It's not just about benchmarks. It's about optimizing the full software stack through CUDA, which is our programming model, up to CUDA-X, which provides higher level libraries, and into the AI frameworks. With CUDA now, one number that we track is how many developers are using that platform and actively developing. And recently, we announced at GTC that we've crossed 2.3 million active developers. We also do a ton of work in the orchestration and management layers of software to make sure that this accelerated computing stack, will work through your common enterprise platforms, whether it's VMware, vCenter and ESXi. We announced a great partnership with VMware to optimize their software stack and bring the AI stack into enterprise data centers, or into kind of modern Kubernetes cloud native architectures. And so we kind of work across all the cloud service providers, into the enterprise platform players, and then out to the edge platforms. And then we work with the OEM ecosystem to test and certify the accelerators and make sure that the full performance of the AI stack can be achieved through their systems. That program we call NVIDIA Certified, and we're working with all the leading OEMs globally. And we start with them and we test kind of 3 things with the OEMs. So one is AI performance, to make sure that their system designs are optimized for kind of the right architecture for throughput and give you the best AI performance for both training and inference. We also test them from a security standpoint because more and more AI is your core intellectual property. You're encoding all of your IP into these AI models, and people want to see that the AI model is securely protected out at the edge. And then, more and more these edge servers, you can think of it, they're going out to areas that aren't in data centers. So you don't have the physical security of the data center. And so the server itself has to protect the intellectual property. They have to be self-healing. You need to support things like secure and measured boot of the operating system. You need to have ways to pass encrypted models to accelerators that are on a PCI bus, and then run those models in a protected way in an AI enclave. So we're spending more and more time, I'll say, in the securing of the infrastructure out at the edge. And the edge infrastructure we see as everything from x86 with discrete GPUs to systems that have ARM plus our GPUs on them. Previously, I think we talked about a number of great customer use cases at Walmart and Siemens and BMW. And this GTC, we started talking about some new customer use cases that we're seeing in terms of edge computing. On the left here is a company called Kion Group. They have 6,000 warehouses. They operate 6,000 warehouses globally, doing a lot of warehouse automation for leading e-tail and retail customers, and doing supply chain optimization, pick and place robots, using AI to streamline the delivery of products, which is really the lifeblood of those industries. Kroger basically is one of many retailers we're working with in the retail industry. They say that you can be measured. They lose about $60 billion a year on shrinkage. So usually products walking out of self-checkout aisles. And so leading retailers are using AI for making sure that produce is kept fresh on shelf, making sure that scans at the self-checkout are accurate, and then making sure the customer experience continues to be improved through their stores. There's less friction in the buying process. So a great I say business optimizations going on with AI and efficiency there. And then in the healthcare industry, every healthcare provider in the world really wants to provide better patient care with less having to have less nurses potentially go out to all these patient rooms, especially with COVID. And so there's great work being done with Northwestern Medicine and companies like Whiteboard Coordinator to have conversational AI nurses, so you can ask questions on when was the last time you got your medicine, and get the voice activated response in an automated way. At GTC, we also announced going into these EGX servers, or this EGX platform is a new architecture that brings networking together with GPUs. So AI, as I mentioned, is kind of a full computing problem, storage, networking, and compute. And so to get high volume data into GPUs for training or inference and do it in a way that's securely, we wanted to start putting these on the same architecture. And so with this, you can have an encrypted data path that flows directly into the GPU for security reasons. But also you can have the BlueField itself, which is an ARM processor, host the GPU. And we call this the BlueField 2X architecture, so that you can start to use AI to look at network traffic. You can use natural language processing techniques to be able to find, to do log parsing and write regex rules by itself, and basically do automated response from a security standpoint in a kind of a self-driving data center. So there's a bunch of research going on here. The programming model, like we have CUDA on GPUs, we announced the DOCA programming model. So obviously the same, I guess, engagement model that we've done with GPUs, we're going to bring to this architecture where, we have a programming model that's, open to everybody to build on. It's going to be future compatible with new architectures. And we're going to keep building higher level frameworks to make it easier for people to get going, engage on these architectures. In terms of data center infrastructure, kind of flipping back to the data center, what leading CSPs have even said is this architecture of moving the services, the infrastructure services, the hypervisor, and software-defined networking off of the CPU and to a coprocessor like this can save you 30% of your compute cores. So this lets you free up infrastructure to really do the compute side of your work on x86 with both VMs and containers. We've published kind of a forward-looking roadmap of Bluefield 2 and Bluefield 2X that shows a really aggressive innovation curve. We think bringing tensor cores to networking is going to be a huge innovation in cybersecurity, and so we're going to kind of keep pushing down this model to drive AI into these cybersecurity use cases. And when you look at this from just a pure raw compute TOPS standpoint, we're seeing a significant increase, obviously 500x acceleration in compute performance over the next few architectures. This future architecture, which we call Bluefield 4, really becomes a foundation for both, I'd say, at the edge of a server in the core data center or as a standalone server in traditional far edge use cases. And so this gives you kind of acceleration in many different form factors in many different locations. And the adoption of kind of this AI, inference across the industry is really broad now, from automotive to consumer internet. All the CSPs are building with Nvidia GPUs. Robotics leaders, automating factories of the future, medical imaging, retail, optimizing, for the customer experience and reducing, loss at checkout. To industrial automation. So AI really is, I think, the biggest force of our lifetime that has the potential and will change every industry. And so it is one of our great challenges that we kind of remain very focused on or very excited about the future potential with. So with that, I'll say thank you, and we'll, I guess, open it up for the panel discussion.